In the machine learning lifecycle, feature selection is a critical process that selects a subset of input features relevant to model training and prediction. Imagine training a model with hundreds of columns, but only a handful actually matter. The rest just add noise, cost, and confusion. That's where feature selection comes in. Instead of feeding every available column into the algorithm, we deliberately choose a smaller, smarter subset. We will start with uncovering 4 key reasons why feature selection matters. Firstly, as we add more and more features, the data space becomes sparse, and many algorithms start to struggle. This is often called the curse of dimensionality. Algorithms such as general linear models or decision trees can perform poorly when they have to learn patterns in very high-dimensional spaces. By selecting only the most useful features, we simplify the problem and make learning easier. Secondly, high-dimensional datasets are also expensive to work with. They require more memory, more processing time, and more experimentation to tune. When we reduce the number of features, we cut computational cost and complexity, which makes our workflows faster and more efficient. Additionally, too many irrelevant or redundant features can cause overfitting. The model starts memorizing noise in the training data instead of learning general patterns. Feature selection removes many of these distracting signals, so the model generalizes better to new, unseen data. Lastly, feature selection also makes models easier to explain. It's much simpler to justify predictions when they rely on a compact set of intuitive variables. Instead of scanning through dozens of columns, we can focus on a small group of features that clearly drive model behavior. Now that we understand why feature selection is important, we will dive into techniques and implementation using Python. One popular family of techniques is called filter methods. They score each feature based on how strongly it's related to the target variable, and then pick the top scoring ones. For classification problems, common scoring functions are chi-square, ANOVA, and mutual information. These scoring functions quantify the statistical relationship between each input feature and the target variable, assigning higher scores to features that show stronger associations and are therefore more likely to be useful for prediction. We can utilize the Python method SelectKBest from the scikit-learn library. There are 2 key parameters for this method: specify how many features we want to keep, and then train a model only on those selected features. To illustrate how it works, we use a credit card customer example to predict whether a customer is likely to churn, which is marked as the attrition flag in the example dataset. A logistic regression model is trained repeatedly using different numbers of selected features and different scoring functions. As more features are added, accuracy improves and then levels off, stabilizing at around 0.88 after roughly 8 features for most methods. Beyond that point, adding extra variables brings little or no gain. Next, we can visualize the feature importance score calculated based on different score functions. Different methods rank features slightly differently, but some variables consistently appear near the top. For instance, a feature like total revolving balance ranks among the top 3 across methods, matching earlier exploratory analysis. Another feature, card category, shows relatively high importance compared with other categorical variables. To validate these findings, we use exploratory data analysis to visualize the relationship between each feature and the target variable, attrition flag. We can see that these 2 features stand out in terms of their contribution to the variance between positive label and negative label groups. To sum up, feature selection is a critical step in machine learning workflow to mitigate the curse of dimensionality, reduce cost, prevent overfitting, while improve explainability. In practice, we can implement filter methods using scikit-learn SelectKBest method based on statistical function like ANOVA, and mutual information to determine which features should be selected for model training and prediction. Thanks for reaching the end. Check out links in the description for more deep dives and related contents. Please like and subscribe if you'd like more videos like this.